Hello, students. Hope you are doing good. Today, I will explain chapter number two, motion. I'm going to skip chapter number one. By the way, this is IGCSE Physics code 0625. It's Cambridge. So, chapter number two is starting from motion. So, first of all, motion is belong to kinematics. Actually, what is physics? Physics is the study of energy, matter, and their interaction. Do you hear about the famous equation E is equal to mc square? That is explain the definition of physics. So physics is divided into different branches. The one of them is mechanics. Mechanics is further divided into two types branches. That one is kinematics and dynamics. So what is mechanics? Mechanics is a branch of physics in which we study the motion of the motion and the causes of the object. So if we just study the motion of the object, that is kinematics. And if we study the motion and causes, why the objects are moving, what has the reason, momentum, force, that is dynamics. But chapter number two is only about the motion. It's mean that is kinematics. So it's a study of motion of objects. In this chapter, we will study about distance and displacement, speed and velocity, acceleration, graphs, and the new thing has been added to this course, that is equation of motion. There are four equation of motion that has been added from AS to IGCSE. So let's start from distance. But before start from distance, we have to know that the scalar and vector quantities. So physical quantities, which you have studied in first chapter, physical quantities further divided into two types, that is scalar quantities and vector quantities. And this is very important definition. Like in the paper, they may ask just select the scalar quantities, just select the vector quantities, and they will give you mixed uh, physical quantities, just like force, displacement, energy, work, power, pressure. So scalar quantities are those quantities which can be described by only its magnitude, just like distance, speed, energy, area, volume. All are the examples of scalar quantities. And vector quantities which can be described by its magnitude as well as direction. For example, distance, the length between 2 points is called distance, but the distance in a specific direction is called displacement. So anything which need direction for explanation, that is vector quantity. Just like velocity, force is also a vector quantity. So let's start from distance and displacement. So displacement, distance is defined as the length between 2 points. Its unit is meter. And displacement is the shortest distance between 2 points, or the distance in a specific direction. From this diagram, you can understand the concept between distance and displacement. For example, this red line represent the distance, and the spellings of the distance are wrong. So just consider distance. And the purple line represent the displacement. So you can see that if you follow the road, so that is distance, the only length between 2 points. And the shortest distance in specific direction, that is called displacement. Both have the unit same, meters. In physics, if the quantities have the same unit, these quantities assume to be same quantities, but the difference is one of them is vector and one of them is scalar. Similarly, the speed. The speed is the distance covered in unit time. How much object move in how much time. So if we divide the distance with time is called speed. Whenever the distance is divided with the time, so we can call it the rate of distance or the distance covered in unit time, that is called speed. The symbols are very important. The symbol of the speed is v, the symbol of the distance is s, the symbol of time is t. What is the unit of the speed? According to this equation, you can see that the unit of the distance is meter, the unit of the time is second, so unit of the speed is meters per second. For example, here's the example. Oh, one more thing. So you can make this triangle to find the unknown value. For example, if you want to find the speed, so that will be equal to distance over time. If you want to find the time, that will be equal to distance over speed. And if you want to find the s, that is distance, that will be equal to speed multiplied by time. For example, this is a situation in which a car is moving 20 meter per second speed and 5 meter, the car covered 5 meter distance. How much time it will, how much time it took to cover 5 meter with a speed of 20 meters per second. So by using the equation of the time, like time is equal to distance over speed. So 5 over 20, that will be equal to 0.25 seconds. Uh, what is velocity? As I told you, there is no difference, but only one of them is scalar, one of them is vector. So velocity is displacement covered in unit time. Only displacement represent the direction. Distance represent the scale quantity with only just magnitude. So displacement covered in unit time in specific direction is called velocity, and the unit of the velocity is meters per second. The same example. Let's assume the same example. Just okay. In this example, we have to find the speed. The speed is equal to distance over time. If a car travel with how much speed? If this car covered 25 meters in 5 seconds, what is the velocity if the car is moving right? So what you will write? Just you will write the direction with the answer. So the answer is 5 meters per second towards right. There are other units, and this is very important. How to convert kilometers per hour to meters per second. Like if you have 60 kilometers per hour, how will you change it into meters per second? So nothing, just you will replace k with 1,000. You know that the value of kilo is 1,000, and how many hours in second? How many seconds in 1 hour? So that is 3,600 and 1,000. So it will be in meters per second. The answer will be 17 meter per second. To keyword to memorize this, like if you change kilometers per hour to meters per second, so you will multiply the number with thousands over 3,600. If you change meters per second to kilometers per hour, so you will multiply 3,600 to divided by 1,000. So you will change the number into kilometer per hour. So this is the number, or you can call 10 over 36 over 1,000 over 3,600. It's the same thing. Okay. Next one is acceleration. Acceleration is a vector quantity, first of all. So it's belong to the velocity of the object. So for the acceleration, change in velocity per unit time, or you can say the rate of change of velocity is called acceleration. Whenever you talk about the velocity, so obviously this direction is specified. So let's change what it means by change in velocity. For example, change in velocity means a car is traveling 20 meters per second. After 5 seconds, its speed increased to 60 meters per second. So what is the distance? Uh, let's pause. First of all, let me explain what is change in velocity. Change in velocity means 60 final velocity minus initial velocity. It should be acceleration here. Like, yeah, what is the acceleration actually? So whenever you want to find the acceleration, acceleration is the rate of change of velocity. For example, change in velocity is final velocity minus initial velocity. So 60 minus 20 is 40. How much time? 5 seconds. So 40 divided by time, 5, that will be equal to 8. So acceleration will be 8. Change in velocity over time. But what is the unit of that acceleration? Unit of that acceleration is, you can see that the unit of the velocity is meters per second, and the unit of the time is seconds. So meters per second per second. So you can write meters per second square. Let's suppose Sometimes some students confuse. So meters per seconds divided by seconds. So whenever you change the division into multiplication, so you will write s over 1 into 1 over s. So just multiply by 1, s multiply by s, so meters per second square. So what is this? This is a symbol of the change, delta, change in velocity over time. You have to understand one thing, that if there is no change in the velocity, the acceleration will be zero. For example, the acceleration for constant velocity will be zero. And what is constant acceleration is? Constant acceleration means there should be acceleration. It means change in velocity, but it should be equal velocity in equal interval of time. That acceleration will be constant acceleration. For example, there are some cases, if you see just black cars, so first 10 seconds, the velocity change 20. In next 5 seconds, the velocity change 30. So in each case, the velocity is being changed 10 meters per second. So here the acceleration is zero. But if you see the first case, that is, uh, in 5 seconds, the velocity is still same, 20 meters per second, 20 meters per second. This means acceleration is zero because change in velocity is zero. 20 minus 20 is zero. So change in velocity is zero. So this is about the acceleration. Now this is a new thing, equations of motion for constant acceleration, because uh, these equations of motions are being have been added to IGCSE from AS, because last time it was in the AS. So there are four equations of motion. Uh, Today I will explain just three, and fourth equation I will explain with the graphs, because the graphs also the part of this chapter. So these equations are only applicable when acceleration is constant, and I already explained when the acceleration is constant. So first of all, the first equation is v is equal to u plus at. V represent the final speed or final velocity. U is the initial velocity, A is the acceleration, and T is the time. Similarly, S is a distance, U is the initial, V is the final, and T is the time, and A is the acceleration. So these are the equations only applicable when the constant is acceleration is constant. Okay, let's prove the first equation. V is equal to U plus AT. So let's start from the definition of acceleration. Acceleration is the change in velocity over time, final velocity minus initial velocity over time. Nothing. You will just do what we'll do. You will multiply time on both sides. So you will get AT V minus U, final velocity minus initial velocity. Just rearrange the equation, make V as a subject. So V is equal to U plus AT. So this is the first equation. Very easy. What is the second equation? Second equation is S is equal to U plus V over 2. What is this? This is the average velocity. What is the average? Means there are two velocities, initial velocity and final velocity. You will add them and you will divide with 2. Okay. So let's start from average speed. What is the average speed? Average speed is the number of speeds divided by time. So V plus U. Let's suppose you notice the speed two times. One time the speed was 20, the second time speed was 30. So what you will do? You will do 20 plus 30 divided by 2. So that will be 25 meters per second. So average speed. So we know that the equation of the uh, S is equal to U plus Vt. Average speed is equal to distance over time. Meaning the speed is only equal to the distance over time. So just put the value of the speed, that is distance over time, and U plus V over 2 as it is. Multiply by time on both sides to cancel this time with S. So you will get final equation of motion number 2, that is S is equal to V plus U divided by 2 times T. For your help, I wrote the names and the symbols. S is a distance, A is a acceleration, V is a speed, that is final, U is the initial speed, and T is a time. Let's go for third equation. Third equation is that one which you have to prove, that is S is equal to ut plus half at square. Here S is a distance, ut, you know that u is the initial speed, t is the time, a is the acceleration. So let's start from second equation. S over t is equal to u plus v over t. I think it's very simple. Just take the value of v from the first equation and put the value of v here. Replace with v, u plus at. So all the equation will be as it is, s over t, u plus at plus u over 2, and simplify it, you will get uh, s over t, u, 2u over 2, at over 2, just separate them, and 2 will cancel with u, and multiply t on all sides, both sides of the equation, and s will be equal to ut plus 1 over 2 at square. So this is the third equation. In next class, I will explain the fourth equation. So till now, we are done. Let me explain something about equations of motion. So you can see that if you notice all the equation, in first equation, there is no distance. So sometime in the question, the distance is not given. So you will use only the first equation. You can see in all the equation, the distance is given. And if the time is not given, so you can see the last equation, v square is equal to u square plus 2. Obviously, you will use the fourth equation. So by using this trick, you can understand which equation we will use for the question. Hope you understood the lesson. And if you have any question, you can ask in the comments. And if you need this lesson in PDF, I will mention my email in the description. You can send the email. I will send it to you. Goodbye.